The alternating series test obviously works for series that are alternating, and what alternating means is that the series alternates, changes from positive to negative, or it could start negative and then go positive and then it'll go back to negative. So for an alternating series, all of these have two parts. They have an alternating part, and with the two that I have here, it's the -1 to the n, or the -1 to the n plus 1. This is the part that makes it change signs, and the non-alternating part, the a sub n, which has to be positive. Now, if you only see the alternating part, then your a sub n is a 1, because 1 times your alternating part is the alternating part. So a sub n is a positive piece. It doesn't alternate. It doesn't change signs. It's not negative. These would make it alternate. So the first thing for an alternating series test is that you have to recognize that it's alternating. And having a -1 when you multiply by a -1 again and again and again is a good clue, but be very careful with that, because if someone had written the sum from n equals 1 to infinity of -1 to the 2n times an a sub n, this doesn't actually alternate, because since it's a 2n in the power, this will always be an even power. -1 to an even power is always positive. So this would actually be a positive series, positive sequence that you're adding up to get the series. If there was a 2n plus 1, then this -1 would always have an odd power, which means that it would always be negative. So don't assume just because you see a -1 that it will alternate. Also, there are other things that make things alternate besides -1 and a +1. It could be something that is equivalent to a -1 and a +1 going back and forth, and sometimes sine and cosine are used for that, so you could see that. So first thing is identify that it's alternating. If it is alternating and the limit as n approaches infinity of your non-alternating part, so the a sub n, if that equals 0, and it is a decreasing sequence, which means that a sub n plus 1 is always less than a sub n, always less than a sub n, then you would actually say that the series could converge by the alternating series test. So examples of series that converge by alternating series would be something like 1 minus 1/2 plus 1/3 minus 1/4, which if I was adding up every single term, this would be a p series, but this one alternates. So this looks like the sum from n equals 1 to infinity. I'll put the alternating piece in -1, and I could put an n, but my first term needs to be positive. So -1 to the first is a negative, so I would put the +1, and then put the p series there, 1 over n. This one actually converges. It alternates. The limit as n approaches infinity of 1 over n equals 0, and it doesn't matter what I put in for my n, the next number I put in is going to make it a smaller fraction, so it is a decreasing sequence. So we could say that this series, the sum of the sequence, this series converges by the alternating series test. What you cannot say is that if you have a series that the limit doesn't equal 0, you don't say that something diverges by alternating series test. If it's an alternating series and you've acknowledged that it's alternating, you'll just write down it's an alternating series, and this limit doesn't equal 0, then the series actually diverges by the nth term test. So to look at some of these, one series we can examine is the sum from n equals 1 to infinity, and that's supposed to be a sigma, of -1 to the n plus 1 times an n divided by 2n minus 1. So this is our first series. Now I want to check and see if it's alternating. I'm suspicious because of the -1, but you want to plug in a few values of n and make sure the signs go back and forth. Or look at this and make sure it changes from even to odd to even, back and forth. So if I plug in 1, 1 plus 1 is 2, it's even, that's a positive. Plug in 2, 2 plus 1 is odd, it's a negative. So this one does alternate, so I'll acknowledge that by writing this is an alternating series. Okay, since it's alternating, I'm going to look at two things. The limit as n approaches infinity of the non-alternating part, so I ignore the negative 1 to the n plus 1 and look at the rest of it. N over 2n minus 1, and I'm going to check this limit. This is an infinity over an infinity, so you can either use L'Hopital's, the derivative over the derivative, which is 1/2, or look at dominant terms. The behavior of this will be like 1/2 out towards infinity. The n's cancel out. Well, it's alternating. My limit is 1/2. It's not 0. So this does not converge by alternating series test. So this is not equal to 0. So I would actually say this diverges by the nth term test. And I'll have 2 more examples on the next video.